Hi everybody, this is Mrs. Lehman. You are on my channel, Math with Mrs. Lehman, and if you haven't already checked out my other videos, when you are available to do that, please make sure you check those out. But why I am on your screen, so to speak, right now is because we are, as a math department, trying to get you guys ready for the upcoming state test and to make sure that you have adequate review. So your computer teachers have been gracious enough to allow us to use this time to review. So even if you're watching this at home later and you're not from the school district I work in, I hope you enjoy these videos and benefit. But if you are sitting in computer class right now, you should have this 2020 Computer Class Math Review Video 1 worksheet in front of you. I'm going to go through, read each question with you twice. We're going to look over the answers, try to eliminate questions or answers to questions that don't make a lot of sense, and then I will show you the ways that I would teach children to approach these problems. So I know different teachers have different methods, but since I'm making the video, you get to experience the Mrs. Lehman approach. So here we go. The first question, I'm going to grab my highlighter here. Hold on a second. Maybe. I'm going to grab my highlighter. All right. So it says, Kim rode her bicycle 135 miles in 9 weeks, riding the same distance each week. Eric rode his bicycle 102 miles in 6 weeks, riding the same distance each week. Which statement correctly compares the number of miles per week they rode? So, first thing we're going to do is highlight or underline, since you guys don't probably have a highlighter with you, 135 miles in 9 weeks, and that's Kim, so that's important. And Eric did 102 miles in 6 weeks. And then our question is, I think some of you learned to underline this with a squiggly line, or if you're in my class, we just highlight with a different color. Which statement correctly compares the number of miles per week they rode? So now we've got to do some math, right? So if we want to find out how many miles per week either of them rode, that's a unit rate question. So that's module 1. So let's label these. Labels are very, well, you don't write with a highlighter. Let me undo that. Grab a pen. You want to label stuff so that you don't get your numbers all mixed up and accidentally say, the wrong name with this. So we have 135 miles. So you should be writing this down on your paper right now. 135 miles for every 9 weeks. All right, and I know in my class, every time we hear for every, we have a ratio alert button that sounds like this. So anytime we hear for every, or per, or anything that would signal that we're talking about a ratio, then we push that button. But anyway, so we are looking at 135 for every 9 weeks for Kim. Now, in red here, this line means a fraction, obviously. It means a ratio we learned this year. And it also means division. So what we're doing is we're going to take 135 and dividing that by 9, because it's top divided by the bottom number. And I jokingly call this, I'll write it in black here so you can see, this line right here above the 135 as the gazinta, because a teacher I used to work with said, what is that called? Or she didn't say what is that called, she said, put it in the gazinta. And I said, oh, I didn't know that thing had a name. And she was like, yeah, it's called the gazinta. And I was like, oh, my mind was blown. But I'm gullible, so I totally believed that. And she was just messing around. Gazinta, goes into. So how many times does 9 go into 135? So this technically doesn't have a name, so I just jokingly now call it the gazinta. So anywho, 9 does not go into 1, so we put a baby x. 9 goes into 13 one time. That gives you 9. Next step would be to subtract. You get 4, right? And you bring that down, you have 5. 9 goes into 45 5 times. So what that means is Kim rode 15 miles for every 1 week, or we'd say 15 miles per week, which means out of 1 week. So that's Kim. All right, now we're going to work on Eric. So Eric, he rode his bicycle 102 miles for every 6 weeks. So we're going to do the same thing to figure out how many miles per week. We're going to find the unit rate, so we're going to use division. The top number goes on the inside of the gazinta, and the bottom number is the divisor, so that goes on the outside. So now we're going to follow that fun little trick you learned. Does McDonald's sell cheeseburgers raw? So does 6 go into 1? No. Does it go into 10? Yes, 1 time. So 6 times 1. We divide, now we're multiplying. Next step is to subtract. We get 4. Then we check, is 4 less than 6? Yes. Bring down your 2. 6 goes into 42 7 times. So 6 times 7 is 42. We're out of numbers and we ended up with a 0 difference. So we are all set there. Our answer is 17 miles per week. So every week he's going 17 miles where Kim is going 15 miles every week. So here are our 2 answers. So let's look at our choices. It says A, Eric rode 2 more miles per week than Kim rode. B, Kim rode 3 more miles per week than Eric rode. C, Kim rode 11 more miles per week than Eric rode. And D, Eric rode 17 more miles per week than Kim rode. So if you look, there's usually a question, answer to a question that is like a trap. So the trap answer here is D, because it says Eric rode 17 more miles per week. So what we found out is that Eric rode 17 miles every week. So that doesn't mean he rode 17 more than Kim. So that is, the option for the impulsive child that wants to say, oh, I figured out 17, and they're super proud of themselves, but they don't want to read anything, so they pick D. So you'll definitely get that wrong if you pick D. So you're looking for the difference between Eric's amount, which was 17, and Kim's amount, which was 15. So if you subtract the 2, you obviously get choice A. Eric rode 2 more miles per week than Kim. All right, let's go on to the next one. So again, as we're going through these questions together, I need you and your other teachers need you to write down all of your work, because math involves work whether you like it or not. Don't be mad at me for saying it. It's just the truth. But let's go on to question number 2. This question cracks me up because it's talking about Arnold working out. But anyway, Arnold's entire workout consisted of 10 minutes of warm-up exercises, 25 minutes of lifting weights, and 15 minutes on the treadmill. What was the ratio of the number of minutes he lifted weights to the total number of minutes of his entire workout? So this question is definitely a ratio question, right? And it's telling you different parts of his workout. And this is asking for a part to whole ratio. So we know part of his workout was 10 minutes of warming up, stretch those muscles, 25 minutes of lifting weights, and 15 minutes on the treadmill. So he's got a lot of activities he's doing here. And it says, what was the ratio of the number, let me change colors, what was the ratio of the number of minutes he lifted weights to the total? So again, this is a part to whole. He did not spend his entire time lifting weights. That was only part of his routine out of, a bunch of things he did. So if we look at these choices, choice A does not make sense, because that would be like saying he lifted weights for every 1 minute he lifted weights. It was 1 minute total of a total workout. So his whole workout was not lifting weights. That's a 1-to-1 ratio. That would mean 100% of his time was lifting weights. So 1 to 2, that'd be like 50% of his time. So he's only doing 25 minutes, but let's see how that compares. 25 minutes of lifting weights, which I highlighted. So 25 lifting, right? And we want to figure out total. So to find total, we have to look at these amounts. 10 minutes, right? 25 minutes, and 15 minutes. Different chunks of his workout. So 25 plus 10, or 10 plus 25, gives us 35 minutes, but he's got another 15 on the treadmill. So we would have a total workout of 50 minutes. So you have 25 to 50. That's obviously not up there. What we need to do is simplify this ratio. So hopefully you already know how to simplify fractions, but essentially you're looking for the GCF of both the numerator and denominator and dividing by that. So the biggest number that goes into 25 that also goes into 50 is 25. So if we divide by 25 on each of these, we could scale that down to 1 to 2. All right, so 1 minute of lifting for every 2 minutes total that he's working out. So the correct answer on this is choice B. Now, in case you're wondering where these questions originated, these were actually questions asked on a state test. So I didn't make these up. These are actual factual questions. And so far, you know, these are pretty straightforward and simple. So let's hope we see some more basic questions like this. Some will be more challenging than others. This next one's pretty easy. When this was on our test a few years ago, a lot of kids actually missed this, and I know I used it on a Module 2 review, or not on a review, but on our actual Module 2 test, and the results were pretty disappointing on this question. And as I went over the results with the kids and we talked about like how you would do this question, I know a lot of kids were like, what? Like, that was so easy. How did I miss this? So I'm not sure if your classes have all gone over this or not, but let's talk about it. It says two whole numbers have a least common multiple of 60. So we're talking about LCM of 60. Each number is less than or equal to 12, and the greatest common factor of the two numbers is 2. So what are the two numbers? So I think a lot of kids saw this question and they checked out. They're like, I don't know what GCF is. I don't know what LCM is. Oh, so long ago I forgot. But let's look at each of these criteria. So let's start with some of the easy criteria. Each number is less than or equal to 12. So look at our list of options. We have 6 and 14, 5 and 12, 10 and 12, 12 and 15. And we have to have less than or equal to 12. So if we look at choice A, we have 6 and 14. We know 14 is greater than 12, so that does not fit our criteria. 5 and 12 are both less than or equal to 12. We can keep that one for now. C, 10 and 12 are both less than or equal to 12, so we can keep choice C. Choice D, 12 and 15, 15 is greater than 12, so we can eliminate just A and D alone based on that one criteria right here. Now let's look at the next criteria, which says the greatest common factor of the two numbers is 2. So a factor, if we know anything about factors, right? Factors are how, or what numbers we would multiply to get a product. So even numbers, for example, are all common in that they share a factor of 2. We are multiplying a number by 2 to get an even number. So we essentially know, based on the second criteria, that it has to be a set of even numbers, all right? So you can eliminate another choice based on that alone, which we can eliminate B, because 5 is not even. So 5 does not have a factor of 2. So what we're looking for is choice C. Now, just to show you how you could have come up with this by doing it kind of the more difficult way, you could find the LCM, and that means least common multiple, which is when you skip count by a number and you figure out where do they first land on the same spot together on the number line. So 10 is going to skip to 20, 30, 40, 50, and they do meet at 60. I'm just going to stop there. 12, 24, 36, 48, and then 60. So the first time they run into each other on the number line is at 60, and it's love at first sight, and that's why I draw hearts around them. So least common multiple, I think of L, love. Anyway, so and the greatest common factor, so we could do factor trees, but probably with numbers that are so low, it might just be easier to do a T-chart. So we could do greatest common factor is 2 of 10 and 12, right? So 10, 1 times 10, or 2 times 5. 12 is 1 times 12, or 2 times 6, or 3 times 4. And when you look for the greatest common factor, so you want one that's on both lists, and the biggest one that they share would be 2, all right? So it fits the criteria that way as well, but honestly, you could get the answer correct on this one, or the question correct, just by paying attention to these two criteria right here. All right, so anyway, let's go ahead and move to question 4. So this one is pretty classic. They love, love, love to ask questions like this on state tests. Let's read it and then I'll talk about it more. So, let's see, is there anything else I wanted to add to that? I don't think so. All right, Omar has 2 3/4 cups of dough to make dumplings. If he uses 3/16 cups of dough for each dumpling, how many whole dumplings can Omar make? So anytime you have a question like this that involves like splitting something up or dividing it into serving sizes, or maybe they love asking questions about gallons of paint, I swear. It's kind of like the trail mix questions of the module. So anytime you have something that's getting split up, divided up, shared amongst people, in this case making servings of something. We've had questions about buckets of water and how many pitchers it would take to fill up this jug of water, things of that nature. I want you to conceptually kind of look at that and think, like, is this something where division would make sense? So Omar has 2 3/4 cups of dough, and he's using this much for one dumpling. We want to figure out how many dumplings can he make. All right, so we have to decide what operation it is. And again, because we're splitting something up into servings, that tells us it's division. So we need to decide what number we're going to put as our dividend, which is getting divided up. What's getting split up here? Is it the dough getting divided, or is it the dumplings getting divided? So you're not dividing each dumpling up, right? You're dividing your dough up. So the dough number is 2 3/4. And each dumpling, we're dividing it into dumplings. That's why we put 2 3/4 first. Not because it happened to be said first. That's not why. It's because the dough is what we're splitting up. So anyway, now that we have, our setup correct, your next step is to get a numerator and a denominator. So we need to get rid of this mixed number. So if you have whole numbers or mixed numbers, you need just a numerator and denominator. So we need to convert this. So to convert a mixed number, we need to multiply the denominator times the whole number. So 2 times 4 is 8, right? And then we add the numerator. So 8 plus 3 is 11. So 11/4 is the same as saying 2 wholes and 3/4 of another, divided by 3/16. Now notice, I have not jumped to the next step yet. You want to make sure you have your problem set up with just numerators, denominators. Then you want to copy, dot, flip, keep, change, flip, drop, switch, flip. So drop the first one down. Switch division to multiplication, and then you flip the second number. So if you're old school Mrs. Lehman in middle school, or elementary school, they didn't teach all these fun new sayings. It was just multiply by the reciprocal. So the reciprocal is a fraction essentially flipped on its head. So there you go. Now you can either simplify before you multiply, or you can simplify later. Personally, I like to simplify before I multiply. So when you do that, you look diagonally and you see, are there any common factors that I can essentially divide by? So 4 and 16, so you look diagonally, 4 and 16, they share a common factor of 4. So if I divide 4 by 4, I'm going to get 1. If I divide 16 by 4, I'm going to get 4. 11 and 3, the only common factor they share is 1, so we're looking for numbers above that, and 11 is not a multiple of 3, so that doesn't work. So 11 times 4 is 44, and 1 times 3 is 3. So you just multiply straight across the top, straight across the bottom. Now we have an improper fraction that needs converting. We want to figure out how many times does 3 go into 44. So 3 goes into 4 one time. It gives you 3. Subtract, you get 1. All right, our next step is to bring down our 4. 3 goes into 14 4 times. That gives you 12. Subtract, you get 2. So we don't have any more numbers, so we want to make this a fraction. So we're going to put 2 up here, and then that 3 that we use as the divisor is going to go as the bottom number. So 14 2/3 dumplings. So you'll see we have choices 13, 14, 15, 16. It may be very tempting to pick choice C, but choice C is not correct. We are not rounding it up. What we have to do is figure out how many whole, complete dumplings he can make, and he cannot make the 15th dumpling. He's got 2/3 of a dumpling there, but it's not a whole dumpling. So Omar can only make 14 dumplings. All right. Now, if I am going too fast for you, you can A, always rewatch it later, or B, pause this. I'm going to try to get as much done as I can in 35 minutes with you, so try to keep up. But you can always, like I said, pause it to get a little more time to write something down, or you can come back to it later. All right, so on the next question, question 5, we are talking about points on a number line. So question 5 says, point A and point B are placed on a number line. Point A is located at -20, and point B is less than point A. Which statement about point B is true? So let's go back through and read this. Point A and B are placed on a number line. Okay. Point A is located at -20. Point B is less than A. That's very important here. All right. Which statement about point B is true? So I'm going to draw a little number line because I think it's good for you to, not just visualize it in your head, but to write it on paper. All right. So we are plotting 2 points. Point A is located at -20. So let's say this is 0, right? -20 we'll say is down here to the left of 0. Negative numbers are to the left of 0. And as we move left on the number line, the numbers get less. So let's see. It says point B is less than point A. Point B has to be less than point A. So we should be thinking, is it on the right or left of point A? Right? We don't know where it is, but we know it's got to be to the left because point B is less than point A. So just to show you with my highlighter, we are looking for a number down this way, all right? Because these numbers to the left would be less than -20. So which statement is true about point B essentially? So it is located at -25 and is to the right of point A. So if we were to put that here, that is definitely to the left of point A. So this part right here makes it wrong. So it is not choice A. Choice B says it is located at -15. So -15 would be, if this were -10, right, this would be -15. Could it be there? No, because we're looking for a number that's to the left of -20. So this is kind of a trap answer because it says -15 and it's to the right of point A. So -15 is to the right of point A, but it's not less than point A. So it's still not correct. Number C, it is located at -25 and is to the left of point A on the number line. So if this were at -25, let's say that's point B. Is that to the left of point A? Yes, it is. Your answer would be choice C. Choice D says it is located at -15 and it's to the right of, to the left of point A. So you've got to know your right from your left, I guess, is really the point there. So anyway, all right, let's move on to the next question. But I did want to mention one thing here. I didn't know if you guys had heard about this, but there was a mathematician who was afraid of all these negative numbers we're working with. Yeah, they were so afraid that they'd stop at nothing to avoid them. Get it? They'd stop at nothing. They'd stop at 0 to avoid negative numbers. Ha ha. All right, let's move on to the next one. All right, we don't have too much time for my cringiness, but just enough. Number 6, the points plotted on the coordinate plane, we need more alliteration in our lives. The points plotted on the coordinate grid below shows different locations in a city. The grid lines represent the city's streets. So we have the theater, the post office, the library, and the museum. And it says the city plans to build a parking lot at the location represented by the coordinates 8, 4. Which building is the shortest driving distance from the parking lot? So again, you're either underlining these or highlighting these. But it says the city plans to build a parking lot at the location 8, 4. Right? So that's where the parking lot's going. Which building is the shortest driving distance from the parking lot? So the key thing is here, not only the coordinates, but we're looking for the shortest drive from the parking lot. All right? So let's find out where the parking lot is. So there's a song which originated from a poem listen to me, poem that, you know, I'm sure you've heard it. They paved paradise and put up a parking lot. It talks about they have the trees in the tree museum. Anyway, you can look it up. So anyway, here is the parking lot. We're going to call it PL, parking lot. So there you go. There's a parking lot. We're looking for the shortest distance, right? So when we're talking about distance in 6th grade on the coordinate plane, it's just how many jumps from one to the other, and we have to either go horizontally or vertically. We're not doing all this diagonal business, all right? So as tempting as it may be for you to say, oh, look at this, from the parking lot to the museum is 2. No, that is not a distance of 2, and hopefully you learned why when you found area of a triangle. So anyway, so to get to the museum, for example, let's start with the theater. Choice A says theater. So look at the theater. You'd have to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 units to get there. That's a drive or a walk. I guess you're parking. It'd be a walk. All right. Then the next one, the library, would be 1, 2, 3, right? So that's 3. Let's compare that now to the museum. Let me erase our path to the library. The museum would be 1, 2, 3. Again, you can't go diagonally, so that's 3. And then the post office, let me erase our trip to the museum. If we were to go to the post office, we'd go 1, 2. So we're looking for the shortest driving distance, which would definitely be choice D, the post office. All right, and you know what? One thing I also wanted to note on this question is why can't you trust a math teacher holding graph paper? You know, you should be leery of that. If you see your math teacher holding graph paper, you should be careful because they must be plotting something. Again, 2 in a row. I mean, come on, guys. All right, number 7 is the last one I'm going to be able to do for a second because then I'm going to pause this and come back to it in a little bit. But anyway, which will be no time to you guys watching this. Which quantity could go in the blank to make the equation below true? So let's go ahead and highlight what we need to, or in your case, underline, because you may not be equipped with a highlighter. And if you are super fancy. Flossy is the new word for fancy, I heard. Anyway, which quantity could go in the blank to make the equation true? All right, so x plus 2x plus something equals 5x. So this question is pretty easy, actually. If you had, I'll draw you a picture. If you had an x, and you had 2 more x's, x and x, and you had an unknown amount of x's, you need this to total up to 5 x's, right? So we have 3 right here. This is 3 x's. We need how many more to get to 5? Well, 3 plus 2 equals 5, but it's not just the number 2, it's got to be 2 x's. So this lesson goes back to combining like terms where you can only add or subtract numbers that have the same exact variables attached. All right, so we're going to move on to the next one here in a second. All right. All right, so now we're on question 8. It says the Frenchtown roller rink charges a $5 entrance fee and an hourly rate for roller skating. The total cost for roller skating depends on the number of hours a person skates. The table below represents the total cost of skating for different numbers of hours. Number of hours H and total cost in dollars C. All right, it says which equation represents the relationship between the cost C and the number of hours H. So this question is really, let's go back first and highlight before I get into it. All right, so if you want to go to the Frenchtown roller rink, you're going to have $5 to get in, right? $5 to get in, and then they're going to charge you an hourly rate, all right? So it's going to cost you more the longer you're there, but even if you just walk in the door and walk right out, you're going to pay $5. So we've got to keep that in mind. It says the total cost depends on the number of hours, obviously. All right, and here's the nice chart of that, and it says which equation represents the relationship between the cost and the number of hours H. So, like I said, if you just show up, it says up top, you're going to pay $5. So even if you spend 0 hours, you're going to pay $5. If you go 1 hour, you're going to spend $8, right? And if you go 2 hours, you're going to spend $11, 3 hours, $14, and 4 hours, $17. So the cost, now you're looking for something that would be true in all of these examples. So choice A says C equals, the cost is going to be 8 times the hour. So that's saying that they're charging $8 per hour, right? So if you go 1 hour, yes, that comes out to 8, but you're forgetting that $5 fee. So that's kind of a trap answer, because number 2, if you were to say 2 hours, that should be 16 and then an additional 5, right? So that, it's not choice A, because if you look, you're not going to be able to multiply your hours times 8 and get that. That doesn't work, right? 3 times 8 does not equal 14. So I'm going to erase that. Let's look at choice B. It says C equals, the cost equals 5 times the hour, 5H, so $5 per hour plus 3. So if we were to take that, if we did 5 times 0, that'd be 0. 0 plus 3, does that equal 5? No. 1 times 5 plus 3 it works for this one. 2 times 5 would be 10, plus 3 does not give you 11, so it doesn't work in this case either. So we can eliminate B because it's just not working out for these dollar amounts. All right, the next one, C, equals 2H plus 7, so double the amount of hours, add 7. So 4 times 2 is 14 plus 7, that's not going to work for 4 hours. 3 times 2 would be 6. 6 plus 7 does not equal 14. You know, so again, C is a garbagey answer. So we're hoping it's choice D, which it is, which is 3 times H plus 5. So this should work for all of these. If you pick an equation, it should work for all of the values in our table. Okay, so again, if we were to plug these all in, so 0 times 3 is 0 plus 5, yeah, it works there. So 3 times 1 plus 5, does that equal 8? So 3 plus 5, that equals 8. That one checks out. 3 times 2 plus 5, 6 plus 5 should be 11. Yep, that checks out. So when you try these out, it all works. All right, let's move on to the next one. I only have a few more minutes to finish this up with you, so I'm going to try to make these last ones pretty quick. What is the area in square centimeters of the shaded part of the rectangle shown below? So they give us a rectangle, but there's a triangle on the side corner here that obviously we don't want to count in that area. So what you need to do to find the area of this is find the area of the outside rectangle. So we know the area formula of a rectangle is length times width. So the area is, now we want to use this and this because we don't want to use 6 because that's not the length of the entire rectangle. So 10 times 14, area equals 140. And I just tacked a 0 on the end of 14 to get that. So centimeters squared. So I'm sure, again, that's an answer there, but we're not done yet because we only want the shaded region. So we need to subtract out all of this stuff. All right, so we know our answer has to be less than 140. So, I mean, common sense could kind of tell you, right, half of this shape is 70, right? Half of the rectangle. So it's more than 70. So common sense should lead you to choice C, right? So let's just test it out. I'll show you how it's actually done. So if we know this whole side on the right is 14 and we know this little section right here is 6, the missing piece is 8, right? So we know this section right here is 8 centimeters. So if we find the area of the triangle, area equals base times height divided by 2, or 1/2 base times height, either way you want to do it. So 10 times 8 divided by 2, you're going to get 80 divided by 2, which is 40, right? So notice they don't have that as a trap answer. But anyway, if you take the area of this rectangle which is 140 centimeters squared, and you subtract out the 40 square centimeter triangle on there, you subtract them, that's how you get 100 square centimeters. So there you go, kids. Number 9, and our last question. Do I have anything there? No. Last question. A few more minutes worth. Oh, I think I'm running out of time. All right. It says the figure below shows the net of a triangular pyramid. The given height is rounded to the nearest hundredth. If all the triangles are equilateral, meaning they all have the same side length, what is the surface area of the pyramid? So pretty much what you need to do is find the area of one triangle. So area of a triangle is base times height divided by 2. So you're going to have 5 times, and they gave us the height up here, 4 and 33 hundredths divided by 2. So you're going to just have to do some multiplication here. So 5 times 433, 4.33. 5 times 3 is 15. That's 15 plus 1 is 16. Carry your 1. That gives you 21.65 divided by 2. So that goes in once. Gives you 2, 0. Bring down your 1. That goes in 0 times, right? Bring down your 16. That goes in 8. And then 2 goes into 5. Well, anyway, that's 16. Do all this stuff. Bring down your 5. We need another 0. 2 goes into 5 2 times. That gives you 4, right? You're going to get 1. You need that 0. So 2 goes into 10 5 times. So 10.825 is the area of one triangle. That's where the trap answer D comes in, because that's the area of one of these. All right. So we need to figure out, we have 1, 2, 3, 4 of these. So they're roughly, 10 centimeters each. So, they're a little over 10. You can tell immediately that that is choice B, because if we multiply 10.825 times 4, you're definitely going to get 43 point something. All right. So anyway, I hate to kind of hurry through that last one, but we're out of time. I'll see you next class in computer. Thanks for watching. Don't forget to check out my channel. Have a great day, guys. Bye.